Telecom world is buzzing with the word 5G. But why do we need 5G? How will 5G shape our digital future? By satisfying the customer needs or demands? What are the key requirements and challenges of 5G? Which key technologies will help overcome those challenges? How will 5G revolutionize smart cities, healthcare, and Industry 4.0? Hello, friends, welcome back to the world of LTE. Previously in the history series, we have talked about how development happened in the telecommunication world over the generations. Today, we are going to talk about the near future of telecom world, that is 5G. In 2020, a tiny thing shook the whole world. SARS-CoV-19 traveled the whole world and restricted the movement of people. From the European Space Agency's operations to small businesses, almost everything started operating remotely. Like water and electricity, the internet also became a basic utility. The world took a giant leap towards dependence on the internet. But according to Moore's law, the number of transistors in a dense integrated circuit doubles about every 2 years, which leads to saturation at some point. Similarly, in mobile telecommunication, by the end of fourth generation, we are already at the peak of high data rates using the existing spectrum. But customer demands is increasing day by day. So what are the new ways of satisfying the ever-increasing customer demand? In the world of telecommunication, spectral efficiency plays the most crucial role. The spectral efficiency is bits per second per hertz. Now the telecom operators get spectrum from the government on lease, and the operator provides the service over this spectrum. So spectrum efficiency reflects how efficiently the operator is utilizing the spectrum. In other words, how many bits can be transmitted per second over a particular radio frequency. In 4G, the operation happens in different frequency ranges starting from 450 MHz to up to 3.8 GHz and in different modes. But as mentioned, we are already at peak of data rate in existing spectrum. So the operators need alternate ways to fulfill customer demand and also to increase the spectral efficiency. The radio of 5G operates in two frequency ranges. The frequency range 1 is below 6 GHz and plans to reuse radio frequencies from other generations including 4G. This will also help telecom operators to transition gradually. The frequency range 2 is in 24 to 100 GHz, which is popularly called as millimeter waves. This frequency range will help scale up to accommodate high bandwidth requirements for services like download of big files or high quality streaming or real-time gaming. And the effective utilization of both frequency ranges will help accommodate the massive tsunami of IoT devices. And to implement it, a new upgraded radio was required. The radio part of 5G is called New Radio or Radio Access Technology Beyond LTE. International Telecommunication Union Radio, ITUR, the governing body set the IMT 2020, which are the standards and requirements for the 5th generation networks, services, and the devices. Some key requirements of the new radio are peak throughput of 100 Mbps to 20 Gbps, latency of 30 to 50 milliseconds to 1 to 4 milliseconds, mobility of 350 km per hour to 500 km per hour, connection density of 10,000 devices to 1 million devices per square kilometer, peak spectral efficiency of 15 bits per second per hertz to 30 bits per second per hertz in downlink, and 3.75 bits per second per hertz to 15 bits per second per hertz in uplink. But how will these features be realized? Well, for that, we need to understand the various technologies that drive the 5th generation of mobile communication and enables the efficient usage of the spectrum. Wireless channel faces several complexities such as multipath fading caused due to multiple paths taken by a wireless signal to reach a user, which leads to extension of symbol duration, thus giving rise to delay spread, and also inter-channel interference where adjacent carrier frequencies overlap with each other. You can click on the eye here to find our videos on OFDMA showing how these are mitigated. The millimeter waves used in the new radio opens up a new world of opportunities in 5G. In our video on MIMO, we have talked about dynamic beamforming and massive MIMO. But massive MIMO is only possible for very high frequency because as frequency increases, wavelength decreases and the size of antenna decreases. thus enabling the usage of multiple antennas in small devices and enabling advanced beamforming. Now, the easiest way to increase the data rate is to increase the bandwidth. However, large chunk of bandwidth is not always available for use. Also, in countries with large number of operators, spectrum allocation is often fragmented. Carrier aggregation is a technology that enables frequencies from different bands to be clubbed together to expand the total bandwidth. The above technology performs good in good coverage, but often the performance of cellular network degrades at the cell edges. We have seen in one of our previous videos that coordinated multipoint enhances the overall system performance through dynamic coordination among multiple geographically separated InnodeBs or cells from same InnodeBs for transmission and reception. Basically, coordinated multipoint enables one device to be served by two different entry points, and also enables a service provider to improve cell edge coverage, which will be very crucial for smart cities. Smart cities will also have massive number of intelligent devices relying upon massive machine-to-machine communication, which might congest the network. So, a heterogeneous network consisting of a macro, small, micro, pico and femto cells can help reduce the congestion. Also for them, good cellular coverage is very important. So relay nodes without a wired backhaul may help fill coverage holes, which will enable a smooth mobile network for the new radio of 5G.
All these technologies has been around us for some time, and we can say 5G is an umbrella under which all these technologies converge. These technologies that we discussed so far will transform the radio side. However, to unlock the true potential, a new radio will require an upgraded core. So other than these, IMT 2020 has other general requirements mostly associated with the core network, like it should be able to support diversity of services. For example, a person binging on Netflix has different traffic requirements than a sensor-based IoT device, and the network should be flexible to support the diverse requirements. The core should also be dynamically scalable. By virtualization of resources associated with network functions, the core should be able to scale up or down based on demand. The core should also be access network agnostic. That is, other than the new radio, people should be able to access services through VLAN, fixed broadband or other modes as well. Now till 4th generation, the core is centralized. To reduce core network or backhaul traffic, a distributed architecture should be adopted. To realize the above requirements and also to mitigate the multi-vendor interworking and roaming problems, the core network should automate the processes as far as possible. In addition to these, network optimization through dynamic data routing, reliability, security, privacy and energy efficiency should be the key focus of the new core. Keeping these requirements in mind, various companies and research institutes across the globe such as Samsung, Ericsson, Nokia and many others have published their own cloud-based architecture. To sum up our learnings so far, we have seen that in 5th generation, both the radio and core side is enhanced. Various technologies have been used to increase the capacity, reduce the latency, increase support to the number of connections, improve the edge coverage, and thus making the network more flexible. Now with great power comes great responsibilities. These advanced features of 5G opens a world of opportunities for the diverse end users, ranging from individual users to large enterprises. The use cases can be broadly classified into 3 categories: eMBB, Enhanced Mobile Broadband for High-Speed Internet, URLLC, Ultra Reliable Low Latency Communication, and MMTC, Massive Machine-to-Machine Type Communication for IoT. Now, in the era of Netflix and 1,000 other over-the-top platforms, watching shows while traveling has become the new normal. However, streaming of live events such as football matches or concerts or other events while on the go has been challenging. With enhanced mobile broadband and a network that has low latency, highly reliable and mobile as in 5G, streaming of live events in high quality even while traveling is going to be a reality. These factors are going to revolutionize the gaming industry as well. Collaborative gaming on the go will become normal. In 21st century, technologies such as augmented reality and virtual reality are already around us. 5G will make the experience smoother. Also in the first quarter of the 21st century, we saw the pandemic. If Corona time has taught us one thing, then it's that when physical presence becomes a challenge, remote schooling or working is possible. Mobile broadband penetration played a huge role in developing countries like India to have a transition towards internet-based education and remote working. The high data rate, low latency and mobility of 5G will make cloud platforms the new normal. There are various platforms like Google Colab or Kaggle which allows cloud computing and collaborative programming. With a 5G network, cloud-based big data handling and machine learning techniques will take huge pace. 5G will also be revolutionary in the auto industry. Enhanced mobile broadband and ultra-reliable low-latency communication of 5G will be a key enabler for massive mobile infotainment. A lot of automakers are also working on autonomous driving that requires a lot of information processing. 5G will make this processing on the go a reality. Another use case in auto sector could be connected vehicles, where vehicles in the network are connected to each other. The fast information exchange between each other because of low latency may help optimize the traffic and avoid accidents. Also, vehicles these days depend a lot on software, which require regular update over the air. Enhanced broadband of 5G will enable faster update on the go. Not only in auto industries, 5G is going to play a key role in other industries as well, such as agriculture, healthcare, manufacturing, etc. For manufacturing, smart factories will take over traditional production in Industry 4.0. Smart factories will require smart machines, robots and machine learning for fault detection or demand prediction. 5G will enable massive machine-to-machine communication, thus taking us away from the Internet of People to the Internet of Things. Ultra-low latency and enhanced broadband will help in executing remote operations. A user can remotely operate devices or even heavy machineries, such as in mines, where safety becomes a challenge for human operations, or in healthcare emergency, where doctors from hospitals or clinic can help a patient remotely by checking vitals, accessing medical records, etc. while the patient is being transported via ambulance. 5G will potentially revolutionize sensor-based IoT applications. Many applications such as personal health monitoring, where smartwatches are used for monitoring heartbeat or oxygen level, or pollution monitoring in cities, where smart sensors are installed throughout the city to monitor the concentration of pollutants like carbon dioxide, nitrous oxide, sulfurous oxide, etc. or for monitoring the condition of soil and atmosphere such as humidity, pH level and other chemical concentration. For smart farming, low latency, mobility and reliability is very crucial. For most of such applications, higher data rate is not useful. Instead, scaling down of bandwidth may help save power and less utilization of spectrum, which means more devices can be accommodated and thus increasing overall efficiency. In a connected ecosystem, the ultra-low latency will help fast processing of information and action. The massive number of IoT devices accommodated with the help of 5G will help the humanity move towards a smart ecosystem. A complete transformation will take time and huge investment, and every operator cannot afford to adopt 5G immediately. That is why the new radio can operate in two modes. In non-standalone mode, existing control plane of 4G is used in 5G. The node of 5G is connected to master node corresponding to 4G. The control plane messages of 5G will reach the core through the master eNode B, but the user plane data will be sent directly to the core. This will enable easier and faster transition for the existing operator. The standalone mode doesn't depend upon 4G and requires complete upgradation of core. So we have seen in this video how the telecom operators will slowly migrate from 4G to 5G. We have seen which are the key technologies that will enable this transition and will be the driving force behind 5G. We have also seen how the end users can take advantages from these advancements and move towards a smarter ecosystem. We appreciate your patience for staying till the end. See you guys in the next video. Happy learning!